Okay, so we're going to be working through the 2017 paper here from National 5 Maths. So our first question, we have given that f of x is x squared plus 3x, we need to evaluate f of negative 5. So first of all, in this I would always write out f of x equals x squared plus 3x. You know what it means when it's asking us to find f of negative 5. So what that is actually telling us is just that x is equal to negative 5 in this situation. So we're having to take that negative 5 and substitute it into our formula. So we end up with negative 5 squared plus 3 lots of negative 5. So negative 5 squared, a negative times a negative always makes a positive, and 5 squared is 25. And then we have 3 times negative 5, which is take away 15. So we just end up with 25 take away 15, which is 10. In this case, 2 marks. Our first mark is for substituting in and knowing that x is negative 5. And our second mark is for getting our answer of 10. Okay, so we've moved on to question 2. Question 2, we have the number of calls received by the police was recorded over 10 days. We have a result shown below, and we need to find the semi-interquartile range of the data. So to find our semi-interquartile range, we first need to find our quartiles. Quartile sounds like quarter, so we're actually finding our quarters of our data. So we need to split it into 4 equal bits. So splitting things into 4 bits, first of all, it's easiest to half it and then half again. So that's what we're going to do. So if we look at our list, we've got 10 numbers here. So if we split that into half, we end up with 5 numbers either side in our halves. So we've got 5 each side of the centre. The centre is our median. We don't need it for this question, but it's nice to know that that's what it is. And then we need to split it again. We split the bottom half in half, and that gives us our quarters. Split the top half in half, and we get our quarter on there. So in the bottom, we have 5 numbers. So if we split this in half, it would be 2.5, so it's kind of in the middle of our third one. So what happens when we're doing these is we end up with 2 either side, and then 1 in our middle, which is our Q1, because it's our lower quartile. Top half, again, 2 and 2, and then we get Q3 in the middle. So our semi-interquartile range, we need to make sure we know the difference between our interquartile range and our semi-interquartile range. So if we think about circles, a semicircle is half a circle. So our semi-interquartile range is when we have to do our halving. So we're having to find the difference between our quartiles, so it's the range in between the two, and we are halving it. So we end up with 250, which I realise I wrote the 5 first there. Take away 218, and then we are halving it. So 250 take away 218 is 32. Half that. So we get our answer of 16 for this one. So our 2 marks, first one is for getting our quartiles correct, and then the second mark is for your answer of 16. And that's question 2. Here we go with question 3. So we have to evaluate 1 5/6 divided by 3/4, giving our answer in its simplest form. So we have this here. Always rewrite the question. It's just a habit. So when we have multiplying or dividing of fractions, we cannot have can't have mixed fractions. We have to have top-heavy fractions. So our 1 5/6, we can't leave as 1 5/6. We need to transform it into a top-heavy fraction. So if I think about this in terms of kind of a visual, so I've got 1, 2, 3, 4, 5, 6, and then 1. So what I've done is I've had one whole bar here, that's 1, and I've split it up into 6 bits because we're looking at 6. So we end up with 6 from our one whole bar that I started with, and then we've got 5 extra bits there. So we've got our 6 and our extra 5, so altogether that means we have 11 sixths. And we're dividing by 3/4. When we're dividing fractions, that is the same as multiplying by the reciprocal, Reciprocal is a long word though, but what that actually in practice means is we need to swap our numbers in our fraction over. So we end up with, instead of 3 on the top and the 4 on the bottom, we end up with it the other way around. So we've got the reciprocal of it. So the reciprocal of 3/4 is 4/3. But basically, all you're having to remember is you flip it and change your divide to a times. So now I can just multiply. So when we're doing fractions, remember it's top times top and bottom times bottom. So we do 11 times 4, which is 44. And then I do 6 times 3, which is 18. It does say in our question, in simplest form. So that means we have to simplify our fraction. We could have simplified before we multiplied, or we can simplify after. It doesn't actually matter. But in this case, our numbers are quite little, so it's easy enough to simplify after. We can see that both 44 and 18 are even, so that means we can half them both. So I'm going to divide the top by 2, and I'm going to divide the bottom by 2 as well. So I end up with 22 on the top, and then on the bottom, 18 divided by 2, which is 9. So let's look at where the marks come from for this. So you get 1 mark for correctly having, so it's worth 2. 1 mark for getting to the line of 11 over 6 times 4/3. So you need to start your simplification and know how to divide your fractions. And then your final answer for getting, final answer gets you your second mark, which is 22 over 9, or if you've changed it back into a mixed number, you would get the second mark for 2 and 4/9. Right, so for question 4, I'm going to do this in a way that may be different from some of you have seen, but I'm going to do it the other way as well too. So we have expand and simplify, and we have 2x plus 3 in our first bracket, and we've got x squared minus 4x plus 1 in our second one. So how I teach this now, anyway, is I teach this using an area method. So what this means is we've got kind of a grid that we're going to fill out. So it's like when you do long multiplication by area in primary. So it's a very similar kind of situation. So our first bracket, we have x, 2x, and we've got positive 3. It's kind of like filling out a number times table grid. And then our second one, we have x squared, we've got negative 4x, and we have plus 1. So our first bracket, it actually doesn't matter which order we put these in. So we've got 2x plus 3, so I've got 2x and I've got 3. In my second bracket, I've got x squared, got negative 4x, or it works out as negative 4x, and I've got plus 1. So I can now just fill this in like a times table square, and then when I'm done, I can kind of combine everything together, and I've got my answer. So 2x and x squared gives me 2x cubed. I've got 3 and x squared, so I get plus 3x squared. I have 2x and negative 4x, so going from in here, it's combining those two together, so I'm multiplying those two. So I end up with negative 8x squared. And I've got negative 4x times by plus 3, so I get negative 12x. I have then got plus 1 and 2x, so I end up with 2x in there. And then I have plus 3 and plus 1, so I have plus 3. We can put pluses in all the things that are positive. So I can now say that 2x plus 3 times by x squared minus 4x plus 1. And I can write out kind of all my terms. So I have 2x cubed plus 3x squared, take away 8x squared, take away 12x, plus 2x, plus 3. So I can then simplify that together, so I end up with 2x cubed. I've got plus 3x and then take away plus 3x squared and take away 8x squared, so that comes to negative 5x squared, or take away 5x squared. I'm taking 12x away and then adding 2x on, so I end up with take away 10x. And then I've got my plus 3 on the end. So more conventionally, most of you, I would expect, who are watching this, will have seen this method instead. So 2x plus 3, x squared minus 4x plus 1. So you've done rainbows or loops. So you've done 2x times x squared, which gives you 2x cubed, 2x times negative 4x, which gives you negative 8x squared, 2x times plus 1, which gives you plus 2x. And now, if you look, these three things are the same as the top three that I have here. So it's just a different way of laying out what I'm doing to make sure that I don't miss anything. And then we do the same with 3, so 3 times x squared, so plus 3x squared. 3 times negative 4, negative 12x. Plus 3 times 1, plus 3. So again, those three last terms, the same as these three I've got on the bottom here. And then can combine them together, same as before, so get 2x cubed minus 5x squared. Oh, I forgot squared in there. Minus 10x plus 3. So the marks for this, it's out of 3. So we get our first mark for any evidence of 3 correct terms. So those first 3 correct terms there, or 3 correct terms there, doesn't matter. Completing our expansion, so getting the whole lot right, gets us our mark number 2. And then for simplifying correctly to our 2x cubed minus 5x squared minus 10x plus 3 gets mark number 3. Right, okay, so with question 5, we have a diagram showing a square-based pyramid that is placed on top of a cube relative to the coordinate axes. The height of the pyramid is half the height of the cube, and A is the point 600. Point C is directly above the centre of the base, and we need to write down the coordinates of B and C. So we need to write what B is, and we need to write what C is. But some of the things we need to know. So important stuff in this question is it tells us that it is a square-based pyramid, and it tells us that the height of the pyramid is half of the height of the cube. So that's everything we kind of need to know, as well as that one coordinate point. So they've told us here that to go from, well, A is 6 points along our x-axis. So that tells us each side of the cube has a length of 6. So I can just kind of draw those in. So each side, every single one, is 6 within my cube. So that means our height is going to be of the pyramid. So the pyramid, which is just this bit here, is half this tall, so that's going to be an extra 3. So B, looking at that coordinate, we know, so from our origin, B is over here. So we're going x, then y, then z when we're doing our coordinates. So we've not gone anywhere in our x direction, so that bx coordinate will be 0. We can see that to go to B, we've gone back 6, so this is our y direction here. So we've gone back 6 to there, so that tells us that our y coordinate is 6. And our z direction is going up the way, and that gets us to 6 as well, so we get 0, 6, 6 is where we go to for B. So with C, it tells us the point is directly above the centre of the base. So the centre of the base of our pyramid, so it's 6 to go all the way along, so it's going to be 3 and 3 for our x and our y direction. So we've gone along 3 there and back 3 in our y direction. And then we need to figure out how tall we've gone. So we know that our cube itself is 6 tall, and then our pyramid is another 3, so altogether that is 9. So we get C, which is 3, 3, and 9. So for this, it is just 1 mark for each coordinate being correct. And so 0, 6, 6, and 3, 3, 9. Okay, so for question 6, we have a diagram showing a straight line joining points A and B. We need to give the equation of the line AB and give it in its simplest form. So when we're finding a straight line, we're aiming for y equals mx plus c. So the things we don't know m and we don't know c. X and y are variables, so they're staying as is. So we need to be able to work those out. So first of all, we need to know what m is. And m is our gradient, and our formula for this is y2 minus y1 over x2 minus x1. So we're using our two coordinates. We've got -1, 6, and we have 3 and -2. It doesn't matter which one is which. The other thing is, because we've got a diagram, it's quite nice to know. So we're sloping down the way and it's quite steep, so we should have a negative gradient that's quite large. So when we're doing this, remember it's x then y, x then y. Doesn't matter which ones are 1 and which ones are 2, as long as they're from the same coordinates. So now I can substitute in. So we have y2, which is -2, take away y1, which is 6, and then on the bottom we've got x2, which is 3, and we're taking away x1, which is -1. So looking at that, on the top, -2 take away 6, so that's getting more negative, so it's going to be -8. And I've got 3 take away -1, taking away a negative is the same as adding, so that gives us 4. So then I've got -8 over 4, which is just -2. There are different ways to do this. I like to sub in to find c rather than using the formula, but you can at this point then use y minus b equals m x minus a. But I like to know, so we've got y equals mx plus c. So we know that m is -2. We have an x value of 3 and we've got a y value of -2, so I can just put all that stuff in. So I get -2 is equal to -2 lots of 3 plus c, whatever c may be. So I get -2 is equal to -6 plus c. So I can add 6 to both sides there, which gives me that c is equal to 4. Well, it gives me 4 is equal to c, and then I can just rewrite it round. So then I can put my c and my m into my y equals mx plus c. So I get y equals -2x plus 4. Okay, so using the method we have here, we get our first mark for finding our gradient. So either of those two bits there. We get our second mark for substituting into here to find finding c, and then our last mark is for writing it as y equals -2x plus 4. Okay, so here we go with question 7. So we have in a triangle DEF, we know that D to E is 8 centimeters, E to F is 12 centimeters. Don't know where that 7 came from. And sine E is 2/3. So we need to calculate the area of the triangle DEF. So we don't have our height of a triangle, so that means we're going to be using our formula. It's in the front of the formula sheet. So we get A is a half AB sine C. So when we have this, we could change our letters about, but I prefer usually to just kind of change the letters on the triangle rather than to change the letters in our formulas. So we know that these two sides need to be A and B because that's what we've got. So we can change the F to an A and we change the D to a B in this case. It doesn't actually matter which of these is which leaves us with C being there. So putting our values in, so we have a half times A, which is 8, B, which is 12, and then it tells us in our question that sine E is 2/3. And we changed our E to a C, so that's telling us sine C is 2/3 in this situation. So doing this, we are going to work from left to right. Why not? So we do a half of 8, which is 4, times 12 times 2/3. So 4 lots of 12 is 48, times 2/3. You can obviously skip some of these steps. 2/3 of 48, so I'm going to have to divide 48 by 3. Because when we're doing this, we divide by the bottom and times by the top. So 48, 4 into 3 goes 1 with 1 left over. 18 into 3 goes 6 times. So we get 16. So that's the same as 16 times 2. And 16 times 2 is 32. And its area, so it's going to be centimetres squared. I've put in far too many lines of working there, and you can do a lot fewer when you're doing this yourself, but that's not a problem because it's only actually worth 2 marks. So our marks in here, first mark is for knowing this one there, so it's a half times 8 times 12 times 2/3. And then second mark is for getting to your 32. Here we go with question 8. So we need to solve algebraically the following inequality. So we have, changing to black ink, there we go. So we've got 19 plus x is greater than 15 plus 3 lots of x take away 2. So first things first, we need to get rid of our brackets. So when we're solving these, brackets don't help us out, so we need to get rid of them first. So our left hand side hasn't changed. We've still got the 15, but we've got 3 lots of x. So we have 3x, and we have 3 lots of -2, so we've got like a takeaway 6. So again, we can kind of simplify things here. So we've got 19 plus x over here. And then on our right hand side even, we've got 15 takeaway 6, so that's the same as 9, plus 3x. With these, I always move the smaller version, the smaller value. So here, x is smaller than 3x, so I'm going to move this one. If you do the other way, what's going to happen is we're going to have negative x's, and then problems happen with our inequalities. And I will do that in a minute at the side, kind of a separate set of working. But if I take away x from both sides, to start me off, this is how I would do it and how I teach it. So we get 19 is greater than 9 plus 2x. And then we want our x's by itself, so I'm going to take away my 9 from both sides. So I get 19 take away 9, which is 10, is greater than 2x. So now I can divide by 2 both sides, which gives me 5 is greater than x. No having to worry about changing signs or directions of my inequalities if I do it that way. However, here, a lot of people like to have your x's on the right hand side. So when we have 19 plus x is greater than 9 minus plus 3x, what some people are going to be inclined to do is take my 3x away from both sides. So I'm going to get 19 take away 2x is greater than 9, just 9. No anything else there. And then I'm going to take away my 19 from both sides. So I'm getting negative 2x is greater than negative 10. So with this now comes the problem. So I'm dividing by negative 2. It's not really a problem, but it's a bit more of hassle. And when we divide by a negative, when we're doing an inequality, we need to remember that what happens is this inequality sign here changes direction. So if it was pointing one way, it now swaps and points the other way. And we still get the same answer, but there's more likelihood for mistakes, especially when we're working kind of with negatives. So I would suggest trying to keep to the method that's in black, but if you would do the method in red, that's fine. You just need to be careful and remember to swap your inequality when you divide by the negative. So in here, first mark is for getting that 3x minus 6 correctly. Second mark is for either here or here. And then our last mark is for either there or there, depending on what set of working you have done. Okay, let's go on to question 9. Right, so with question 9 we have in the diagram shown below, we have been told that ABE is a tangent to the circle at centre 0, and we know that angle DBE even is 58, which is on our diagram. And we need to find the sides of angle CAB, which they've shaded in here as well nicely for us. So, important pieces of information we've been given, which is this one. So tangent to the circle. Tangent to the circle means that things are at 90 degrees. So that's telling us we have a 90 degree in there, and we've got a 90 degree in there. So that tells us our 58 plus this angle in here add up to 90. So we can work this one out. So if this is 58, that tells us that that one there is going to have to be 32 degrees. Okay, so that's it to start us off. The other things we need to know is in a circle. So this is our centre. O to B is a radius, so is O to D, so is O to C. They are all the same, and that means that any triangles they make are going to end up being isosceles because the lengths are the same. So that's telling us this is the same length as this, and that's the same length as that as well. So we've got a lot of isosceles triangles in here. In an isosceles triangle, we have two angles that are the same, and then one that is different. It's the two at the bottom of the sides that are the same length. The one where the two similar sides meet, that's our different angle. So we have 32 and 32. So in here, we know triangles, they have to add up to 180. So if we do 180, we need to take away our 64. So carry over. So in here we have 116 degrees. Other things is we have here straight line and a straight line with a point. These two have to add up to 180. We've just done a calculation here which shows us 180 take away 64, it gives us our 116. So that tells us in here is 64. So now we have another isosceles triangle. So we know that this and these two have to add up to 180. We know this is 64. Again, because we've done 180 take away 64 already as 116. We know that these two have to add together to make 116, so we can half that 116. So when we half that 116 divided by 2, we have 1 divided by 2 is 0 with 1 left over. 11 divided by 2 is 5 with 1 left over. And 16 divided by 2 is 8. So we're going to have a 58 in there, and we're going to have a 58 in there. So now we have a 58, so that's a 32 as well, because we've got another tangent in here. So in there, tangent is telling us that this is 58. If that's 58, that's 32 as well. Another thing that we've missed, and I haven't spoken about, is the fact that this is the diameter of the circle. So that tells us as well that this angle C to B to D has got to be 90 degrees too. So I could have figured out my 58 that way, in fact, rather than the way that I have done it. So I've kind of found out more than I actually needed to. So we've got 32 here, which is fine. We have still got two things left in this triangle to find. So here we've got 180. So we've got 58 and something, which is going to give us 180. So one more calculation, 180 take away 58. So we have 10 take away 8, which is 2, 7 take away 5, which is 2, and our 1 take away nothing, which is 1. So in here we have our 122 degrees. So we know that still triangles add up to 180. So this one, and the one we're trying to find all together make 180. So let's add those two together. So when we add together the 122 and the 32, we get 154. So to find my last one, I'm doing my 180 take away my 154. So borrowing from the 8 to make it 7, 10 take away 4, which is 6, 7 take away 5, which is 2, 1 take away 1, which is 0. So in here we have 26 degrees. So we should write at the bottom just to be safe. So angle CAB equals 26 degrees. So depending on which way you've worked this out, the marking scheme is slightly different. But you get 1 for angle OB to D, which is 32. And that's the same either way. If you've then worked out angle OD to B is 32, that's our second mark in here. That's one way of doing it, and then getting to our final answer of 26 would be mark 3. Our other option when we're doing this, depending on how you've worked it out, would be your second mark would be for doing O to C to B, so this one in here is 58. And then our answer of 26 degrees. But if you filled out them all and you've got the correct answer of 26, you would get all 3 marks. Okay, so question 10. We're almost getting there, but I think there's 15 questions. We need to change the subject of the formula to B. So we have F is equal to T squared plus 4B divided by C. So when we're changing the subject, what we're effectively doing is it's like we're untangling a knot. So we're undoing things that have been done. So whatever we're doing, we have to do the opposite. First things first, a lot of people like to write it with the thing we're trying to find on the left hand side. So you just write it swapping the sides of the equal signs. So here I've got this fraction. So fractions mean division, and we need to do the opposite to undo our knot if we're thinking about it that way, or to rearrange we need to do the opposite. So we've got to divide by C, so we need to times by C, and whatever we do to one side I have to do to the other side as well. So there we're going to get T squared plus 4B, so we just get left with our numerator or the top of our fraction, equals F times C, which I can just write as FC. So now, looking at my left, I've got 4B. I also have my T squared. T squared is there, but we don't need it because we're aiming for B. So T squared is there and it's positive. So to undo that, I need to take it away. If I take it away from one side, I need to take it away from the other side as well. So then I get 4B is equal to FC minus T squared. Also, apologies for dog noises in the background of this, if you can hear her. Yep. If you can't, great. If you can, apologies for that. So here we've got 4B. So 4 times B, so we need to undo that. And again, so undoing timesing is dividing. So I divide both sides by 4. Division and fractions, same thing, so I can just write it as one big fraction. So FC minus T squared over 4. So where do my marks come for this question? First mark comes for here, so multiplying by C correctly to get FC, and on the other side T squared plus 4B. Second mark's for getting to 4B equals FC minus T squared, and then finally third mark there. So our 3 steps of working get us 3 marks, and that is it for changing the subject. So question 11, we need to express these 2 fractions as a single fraction in its simplest form. So we have 3 over a squared take away 2 over a. So 2 add or subtract fractions, but they need to have a common denominator. So this one here is a squared, which is the same as a times a, and this one is a. So to make these the same, the common kind of factor of what we're looking for a squared and a is in fact just a squared. So they both are going to end up over a squared, so we have our common denominator. You can make it a cubed, but then we're kind of getting a's everywhere that would cancel out, because we're always looking for our lowest common denominator. So our first fraction, to go from a squared from here to here, a squared to a squared, I haven't done anything, I've just times by 1. So whatever I do to the top of my fraction, I have to do to the bottom of my fraction as well. So there, the top just stays as a 3. Looking at the fraction on the right, here, to go from a to a squared, what I have done is I have times by a, and whatever I do to the bottom, I have to do to the top as well. So the top of that becomes 2a. When we're doing this then, we can then just do a subtract, so we end up with 3, take away 2a, because we're just doing the left numerator, take the top of the left fraction. So here, 3, take away this. That's all we're doing. And then our bottom stays, bottom of the fraction, or the denominator, stays as a squared. So marks for this one, which is quite straightforward, was for seeing that your common denominator should be a squared, or if you've gone for a cubed, that's okay as well. And then our second mark is for our fully simplified version. So if you'd done it with a cubed, you would need to simplify there, because in the question it says very specifically in its simplest form. So if it could have been simplified, you would need to do so. That's question 11. Okay, so here we go with question 12. We have gym members who've been asked to fill out a questionnaire to rate the quality of the service provided. They're asked to give the rating on a scale of 1 to 6. Here's the rankings given by 5 members. And we need to, in its simplest form, write our standard deviation as A root B and find the values of A and B. So we know that our standard deviation formula, where there's 2 different ones, I use this one. So I use standard deviation as the square root of the sum of x squared minus the sum of x squared over n all over n minus 1. So for this, I don't need to find the mean, it has an asterisk for it, but I need to find my sum of x and my sum of x squared. So to do that, I need to find my x and my x squared values. So here x is 1, 4, 6, 3 and 6. So my sum of x, so what I get when I add those together, that's what the word sum means. So 1 add 4 is 5, add the 6 is 11, add the 3 is 14, add the 6 gives me 20. Other side, 1 squared is 1, 4 squared is 16, 6 squared is 36, 3 squared is 9, and 6 squared is 36. So I need to add those up. So in this case, I'm just going to do a really basic chimney sum, just so I don't get things wrong in my head. So I'm adding the big ones first, so 36 add 36, 6 add 6, 12, 3 add 3 is 6, add the 1 is 7. So then I'm going to do 72, add my 16, 2 and 6 gives me 8, 7 and 1 gives me 8, and then the last 2 numbers I've got to add are 9 and 1, and I can add those because they 10 together. So my sum of x squared, which is what I've got there, is 88. So I can put my numbers into my standard deviation formula. So my sum of x squared, which is what comes first, is 88, minus sum of x squared, so that's 20 squared, divided by n, which is how many there are, which is 5, all over 5 take away 1. So now simplifying this a little bit. So 88 minus 20 squared, which is 400, divided by 5 all over 4. So 400 divided by 5, just doing this to be careful, 4 into 5 is 0, remainder 4. 40 into 5 is 8, so it's 80. So here I've got 80, take away 88 even. No, 98. Apologies, I've miswritten that, haven't I? I said I needed to add on my 10, and I need to make sure that I do add on my 10. So my sum of x squared wasn't 88, it was 98. So in here, again, we've got 98, and that's 98, and that'll be 98. So I've got 98, take away 80, over 4, square root. So I'm going to go over here because I don't have any space to keep going down the page, but you would in your exam. So here, square root 98 take away 80 is 18. So I've got the square root of 18 over 4. Here, when we've got square roots, we can simplify it so it becomes the square root of 18 on the top and the square root of 4 on the bottom. Square root of 18 we need to simplify. So when we're simplifying a square root, we're looking for its factors. So for 18 we have 1 and 18, and we've got 2 and 9, and we have 3 and 6. So we're picking the pair that has a square number, which is this one there. So I want to rewrite that as the square root of 9 times the square root of 2. The order doesn't really matter, I just put the square number first, and 9 is my square number. Square root of 4 is 2, so there we go. And then on the top, the square root of 9 is 3, so we end up with 3 root 2 over 2. Now asked for finding the values of a and b, so we should write them out. So a equals 3 and b equals 2. So this was a lot of marks for this question, 4 marks. So let's see where our marks come from. So our first mark is there for our sum of x and our sum of x squared, so 20 and 98. Second mark is for getting in here. I've realised I didn't write that 9 back in. But that's where my second mark is, for that line of working in there, for having substituted in. You get your third mark for getting to the square root of 18 over 4. And then finally your marks for saying a is 3 and b is 2. And once you've got your final answer. You're also, it says specifically in the marking scheme you can leave it like that. You didn't have to write it as a was 3 and b was 2. That's it for question 12. At least with this kind of question, if you can get part of the way through the standard deviation question, it's worth quite a lot of marks, so it's worth giving a go even if we can't get right to the end. Okay, so question 13, we have a graph, that's just my dog, sorry, that shows two straight lines with the equations below. So we've got 3x take away y is 2, and we've got x plus 3y is 19. We get told that the lines intersect, which means they meet at point P, which we can see there, and algebraically we need to find that coordinate. So what we're doing here is in fact a simultaneous equation. Simultaneous equations are all about finding a point where two straight lines meet. Even if it's in context, that's still what you're doing. So we need to first of all look at our two equations. I'm going to write them out. So we have 3x minus y is equal to 2, and we have x plus 3y is equal to 19. So we can see that looking at either our x terms or our y terms, we don't have any consistent numbers in front of them. So we're going to either have to scale one or both of these. Looking at this, I would suggest that it's going to be easier with this 19 to scale this first one. So if we make this 3y, and this one's 3y as well, well, this one will be negative 3y and that one will be positive 3y, but we'll deal with that when we get to it. So to do that, we can multiply our top equation by 3, and then our second equation can just stay as is, multiplied by 1. So when we do that, our first equation becomes 9x, take away 3y is equal to 6, because I've multiplied everything. In the bottom I have x plus 3y equals 19. So now, these two equations we can effectively do either a giant addition or subtraction. Looking at our terms which have the same number in front of them. So here we've got 9x and x, nothing, I can't add those or subtract them to make 0. However, looking at my y's, I've got negative 3y and plus 3y. I need to make those combine to make 0. They're opposites of each other. So when things are opposites of each other, you add them together, and when you add them together, you get 0. So if I'm just doing a giant add here, so what I have to do is so 9x plus x, so I get 10x. Negative 3y plus 3y, which is 0. They cancel each other out. There is 0, like 3 lots of 0 pairs. And then we've got 6 plus 19, which is 25. So then I get x is equal to 2.5. Because I've divided there by 10 on both sides. So 10x divided by 10 is x. 25 divided by 10 is 2.5. Right, so we now need to find out what y is. So we can substitute it into either equation. It doesn't actually matter which one we want to do. So let's see. So let's use our x plus 3x take away y. Let's use that one. So we have 3x take away y is equal to 2. So that's telling me that 3 lots of 2.5 take away something gives me 2. So 3 lots of 2.5 is 7.5. Take away y equals 2. So in there we can see that y would have to be 5.5. So now it said, though, we need to find the coordinate of P. So we need to write this as a coordinate. So P is in fact in this case 2.5, comma 5.5. So where do the marks come for question 13? It's out of 3 marks. So our first mark is for some evidence of scaling. So here, showing you've times by 3 there correctly to get the same thing there. We get our values of x and y. And that's our mark number 2. And then our third mark is for stating them as a coordinate, as long as they're correct. For mark 2, actually, you can find values of x and y that are incorrect, but obviously it's always best to get the correct answer. But that's it for question 13, and the marks you get for doing that simultaneous equation question. Right, so we've got question 14, which is a parabola. So we have the equation shows, the graph below shows a parabola with the equation of the form y equals x minus a all squared plus b. We know the axis of symmetry is at negative, x is negative 5, and we need to find the value of a. So for part A, it's saying state the value of a. When we are looking at our parabolas in this form with completing the square, this point here has our our coordinate, which is negative a b. So whatever value our x value is, that the negative of that goes into our bracket and our b value is there. So we can say, if we know our axis of symmetry is negative 5, that in fact is telling us that our coordinate, the x value of the turning point's coordinate is negative 5, which tells us that a in this case is going to be 5. So we know that the point negative 3, 8 lies on the parabola, so we need to calculate the value of b. So this is just a case of substituting in things that we know. So we know y equals x plus a squared plus b. So we know that x is negative 3, we know that y is 8, and we know that a is 5. So we can put all those things in, so we get 8 is equal to negative 3 plus 5 squared plus b. So we get 8 is equal to negative 3 plus 5, which is 2, so 2 squared plus b. 2 squared is 4, so 8 is equal to 4 plus 4, so b has to be equal to 4 in this case. So it looks like it's a parabola question, but really this was a question more about substitution and understanding of parabolas in that case. So our first marks here, we get 1 just for knowing a was 5 from the fact that it tells us our axis of symmetry. For part B, it was for substituting in, and then for getting that b was 4. So we're on to our last question of paper 1. So we've got, in the diagram below, TS is parallel to QR. TS is 5 centimeters, QR is 7 centimeters, SR is 2.6. P to S is x centimeters, and we need to find the value of x. So in this case, I think the best thing when we've got triangles inside triangles is to draw them out as separate things. So we've got our first triangle, which is P, T, and S. There we go. So that's x, and that is 5. And then we have our big triangle, which is P, R, and Q. And we have that 7 centimeters. Put my centimeters on there. And then this one along the bottom, we've got our x, but we've also got an extra 2.6. So it is x plus 2.6 centimeters. So we need to work out our scale factor here. So it's a linear scale factor because we're going from one line to another. So we have our scale factor here, and we've got this one here. So we work out our linear scale factor. It doesn't actually matter what order we're doing this in, to be honest, because we've got unknowns as both of these. So if I work out my linear scale factor, we know that it is, if we're enlarging, let's say we're enlarging, we're going to end up with 7 over 5. So what this is telling us is that to go from our small value to our big one, we have to times by 7 over 5. So that means that this value here is the same as 7/5 of this one. So we get 7/5 times x is going to equal x plus 2.6. So now we can actually solve this because we've just got ourselves an equation. So 7/5 of x is the same as x plus 2.6. We've just got equating two things here. So there I've got 7 over 5. I don't like having a fraction, so I'm going to times by 5. When I do that, I'm going to times this whole side by 5. So I'm going to get 7x on this side. It's going to be equal to 5 lots of x plus 2.6. So I need to multiply that out. So I get 7x on this side, easy enough. This one, I have 5x, and then I've got 5 lots of 2.6. So I do 2.6 times 5. So 6 times 5 is 30. 2 times 5 is 10 plus 3, so I get 13. So I get 7x is the same as 5x plus 13. Take away the 5x from both sides, I get 2x is 13. I take half of both of those, I get x is 13 divided by 2, which is 6.5 centimetres. So last question, where do my marks come from? So in this one, my marks come from either 7/5 or 5/7. Depending on which one you do, obviously. We're starting to form an equation. So here, the way I've done this one, x 7/5 of x equals x plus 2.6, that one in there. And then for getting x is 6.5 centimetres. There's a few different ways to do this. If you've tried this yourself first and done it a different way, check the marking scheme to see how you would get to the answer, see if your answer works as well for how you do this one. So hopefully this has been helpful for you. This is been the 2017 paper. If you need any other advice on any of these questions, or you aren't totally sure on what I've said, feel free to leave a comment and I'll reply. Thank you very much, and I hope that the rest of this playlist is helpful as well with the other papers from the other years, and good luck with your exams, whenever those may be.